right, so this lesson is rate of change and slope, and I don't want you to worry about this. Get to this later. I'm going to go over a couple of the definitions with you. Like, I don't want to write them down, but the rate of change is a ratio that compares how much one quantity changes relative to a change in another. So a ratio means that it's a fraction. And what that means is it's the change in y, because those are the values we're talking about, the change in y over the change in x, which can be written this way. Sometimes we see it written this way. Or maybe you've heard about it as rise over run. Okay, rise being the change in y over the change in x. And when you did hear about rise over run, we knew that that was called slope. So rate of change and slope are the same thing. Okay, they're the same thing. And we find them the same way. Okay, we find those the same way with the formula for slope, which is this, and you must know this. Okay, it's absolutely imperative that you do. The slope formula is y2 minus y1 over x2 minus x1. Okay. And this is where x cannot be 0. It's just curious, if you had a fraction where x was 0, what is the answer to this? Well, if x equals 0 in this problem, this is what's called undefined. Undefined. This isn't possible. So remember that, because I'll show you what an undefined slope is in just a minute. So if I give you two ordered pairs, I want to use this to find the slope. We're going to start with 1 and -3 and 3 and 5. And for the moment, I'm going to go ahead and label those. I don't normally, but I'm going to so I can show you how to do this. This is going to be my x1. This is y1. This is x2. This is y2. So now I'm going to take these numbers, x1, y1, x2, y2, and I'm going to plug them into this formula. So I'm going to have 5 minus -3, okay, 5 minus -3 over 3 minus 1. And I'm going to simplify that. Here's a double negative, so I'm going to mark it. So I'm going to get 8 over 2, which is 4 over 1. So that means that the points on this graph are going to change. They're going to rise 4 and move over to the right 1. All right, let's look at another one. Okay, so I'm going to do -9 minus 11. That's my change in y over my change in x, which is going to be 24 minus -8. So I'm going to get -20 over, mark that, 32. And the thing about slope is this. This is a correct answer. However, it would be marked wrong. You have to reduce your slope. In this case, these are both divisible by 4. And that's going to give me -5 over 8. Okay. You must reduce slope. The thing about it is, if we were graphing and you had a slope of 100 over 300, and you plotted the first point, would you really want to count up 100 and over 300 when you could count up 1 and over 3? Always reduce. Now, sometimes you have a missing coordinate, and you have to find it. I'm going to get another piece of paper so I have room to actually write on this to show you this problem. Okay, you know the slope formula is y2 minus y1 over x2 minus x1. So we want to make sure we remember that. So in this problem, I've got a 6 and an x, and that's probably a little confusing, but no, that'll work. 6 and x. In here I've got a 3 and 3, and I'm telling you that in this problem your slope equals 2, and I need to find out what this coordinate is. Okay, I need to find out what this coordinate is. Now, don't be confused thinking this is x and y. This is just an unknown term. Okay, so that's the variable that I've chosen, so don't be confused by that. I'm going to solve for this so I can figure out what this coordinate is. I'm just going to plug them into the formula. Remember, this is x1, y1, x2, y2. I'm going to plug them into the formula just as it's written. So I'm going to do 3 minus x over 3 minus 6. And all of this equals 2. I'm going to simplify and I'm going to solve this. So I've got 3 minus x over negative 3 because 3 minus 6 is negative 3 and equals 2. So now, to undo this fraction, I'm going to multiply. I'm going to grab this negative 3 and I'm going to move across the equal sign and multiply it times this 2. So I've got 3 minus x equals negative 6. I'm going to subtract 3 from both sides, and I've got negative x equals negative 9. And I don't want negative x, so I need to divide both sides by negative 1. So x equals 9. So my missing coordinate in this ordered pair is 9. Let's see if I can do another one. Maybe. I don't seem to have one, so I'm going to make one up. Okay. Let's see. We'll do 1. And I'll put a y here as to not confuse us this time. And a 3. And a 5. And we're going to say the slope on this one is 4. So I'm going to plug these into the formula. So 5 minus y, okay, that's my change in y's, over 3 minus 1 equals 4. So simplify your denominator. So we end up with 5 minus y over 2 equals 4. And now solve this equation for y. I'm going to multiply by 2. I get 5 minus y equals 8. Subtracting 5 from both sides, negative y equals 3. And divide by negative 1 because I'm not looking for negative. So y equals negative 3. And that is the solution. That's what this missing point is. And that's going to be a skill that you're going to need. Now, another way that we calculate slope is what's called the counting method. And I'm just going over this just in case something shows itself on the homework. And on the counting method, you usually have a graph, and this isn't going to be drawn to scale, so I'm going to make this kind of an easier problem so I can count properly. And let's say I have a point here, and that point is negative 1, and we'll say we have a point here at 1, 2. The counting method, I'll draw my line. Okay. The counting method is when I usually start on the left side of the graph, and I count up and over. So I count up or down first, then left or right. Okay, then left or right. So in this case, I'm going to count up, and because I'm counting up, my slope's going to be positive. So I'm counting up 1, 2, 3. So I counted up 3. That's the change in y. And then I'm going to count over 1, 2. So I counted over 2. So my slope, counting up 3 and over 2, is 3 over 2. And that's the counting method. If you have questions, please ask. But there you go with rate of change and slope.